Okay, this is a video of the notes on laws of exponents. And so the first slide is an introduction slide here. After today, you'll be able to simplify exponential expressions using laws of exponents, express radicals, which are roots, using rational or fractional exponents. And the agenda is we're going to take notes today. I'm going to put the copy of the Google Slides on the module. I think there's a way you can take those and put them into Cami if you want to make annotations in Cami, or if you just want to type things on the Google slide, you can. So let's go to the next slide. So reminders, the mini quiz, I made it a practice grade. It's on. It's due Tuesday, October 6th at 11:59 p.m. And then I made another mini quiz on Desmos. That's going to be due Thursday, October 8th at 11:59 p.m. So why I did that is some students emailed me after they took the first mini quiz and asked me for a retake. So I made it a practice grade. And then the Desmos would be in the all task or all assignments category. So you can take the practice quiz. If you don't like your score for the practice quiz, you can take it over. I gave you a second chance at that, and then do the mini quiz on Desmos by Thursday, October 8th at midnight. So the Wednesday work that you can do, and most of you should not be making up any map R or map M. So on that day, you should do the exponents practice on Desmos, very similar to these slides. And then there's the exponents practice on Khan Academy. And make sure you do the mini quiz on Desmos. All right, let's rewrite the following term. So x squared, what does that really mean? That means x times x. So let me get the pen here. So that really means this, x times x. And what does r to the fifth mean? It means r times r. So the dot means times. So we multiply r together 5 times. And what is the meaning of this? It's m times m times m times p. And 7 to the third means 7 multiplied together 3 times. All right, so if we make it harder, if we multiply these together, it would be x times x. We don't want to do this every single time, but I'll do it on this slide to illustrate what's going on here. So x squared times x to the fourth. What does that equal? 1, 2, 3, 4, 5, 6. That equals x to the sixth power. And then this is actually y times y times y times y. 7 times 1, 2, 3, 4, 5, 6, 7. And then y cubed is y times y times y. So here I can simplify, and that will be y to the fourth. Then here, a squared divided by a to the seventh, be a times a. And then 7 a's multiplied together on the bottom, or in the denominator. So 1, 2, 3, 4, 5, 6, 7. So 2 of these would go away. What's left on the top would be a 1. And what's left on the bottom is 8 to the 5th. Cross that one off. And sometimes we write it like this with a negative exponent. I think that might be on the slides now. So 8 to the negative 5th means the reciprocal with a positive exponent. So a reciprocal would be 1 over a to the positive exponent of 5. And I'm not going to write this all out here. Well, it'd be b times b, b times b 5 times. I'm going to go ahead and write it out just to show you what happens here. 3, 4, 5. That's b to the 10th. 2, 4, 6, 8, 10. And this one, you can write either way here. All right, so here we want to generalize what we just did. So if I have the same base to a power multiplied together, like bases, and I'm multiplying, then I'm going to add the exponents. So x to the m plus n. If I have like bases and I'm dividing, I'm going to take that base and then subtract the exponents. And then if I have a negative exponent, it's just 1 over. Let me do that again there. X to the m. All right, and then if I have a power to the power, let's just multiply the two exponents together. Product to a power, the x to the m times y to the m. A fraction to a power, you take the numerator to the power and the denominator. So x to the m over y to the m. And then anything to the 0 power is 1. All right, so let's practice here. So here I have like bases, and C is the like base, and I'm multiplying these all together. So what am I going to do? Let me C to the 3 plus negative 7 plus 0. Let's C to the negative 4th. So if I tell you don't write anything with negative exponents, then write it as a fraction or the reciprocal. All right, this one, you're going to multiply these two together. X to the 5th times x to the 7th is x to the 12th divided by x to the 9th, and then subtract the exponents. It would be x cubed. The other way you could do this is do this first here. So if I divide first, it'll be x to the negative 4 times x to the 7th. I get the same answer. All right, so if I do what's inside the parentheses first here, this is y to the negative 6th, and then to the negative 5th power would be y to the 30th. Or just multiply all those powers together. And then this one, there's different ways you can do it, but if I do what's in the numerator first, e to the 4th, b squared, c to the 10th, and then divided by a to the negative 6th, b cubed, c cubed. So subtracting these two, I get a to the 10th b to the negative 1, so that would go in the denominator, b the first power. And then subtract these, I get c to the 7th in the numerator. So this would be b to the negative 1. So I just wrote it in the denominator instead of writing b to the negative 1 here and then have to put it back in the denominator. And I was running out of room anyway, so this one, you can do what's inside the parentheses first here. And that's probably what I would do because by order of operation. So this would be, I would do what's in the numerator, x to the negative 3 over x to the negative 6 to the 4th. And now doing this math here, negative 3 minus negative 6 is x cubed. The 4th power is x to the 12th. And then the challenge here, 2 to what power gives me a 1 here. It would be to the 1/2. Because 2 times 1/2 is 1. So that's kind of an introduction to the rational exponent. So this would also be 1/2 here, x squared to the 1/2. So the square root of x squared is just x. So this is actually, what you should notice here is this is the same as this. X squared to the 1/2 power. So these two are actually the same. So this would be a 1/2 x squared to the 1/2. This is equal to x. And then what needs to go in here? A 1/2 again. So the x to the 1/2, or the square root of x squared, is just x. This is our little introduction to the rational exponent. Something with a fraction as an exponent. So this would be x cubed to the 1/3, and then this would be x to the 1/3 cubed. So how could we express this as radical? It would be like this, x cubed. Whoop. Let me make that a little bit better. So the cube root. And then this one would be the cube root of x and to the 3rd power. So those both are equivalent there. Whether I write it like this or like that, I end up with the equivalent expression because when I multiply the exponents together, I get x to the 1st. So this is equal to x, and so is this. So summary, the nth root of x is equal to x over x to the 1 over n. And the nth root of x to the m is the same as this. So here's the root in the denominator and the exponent goes in the numerator. All right, so if we want to practice this, I'm going to change this to a rational exponent, x to the 1/5. So this is actually x to the 1/2 to the 5th power. So this is x to the 5/2. And don't write it as 2.5 because this is the root and this is the exponent. So leave it like that. Is an improper fraction. This one is the 4th root of the square root of x. So you have this, which is x to the 1/2 to the 1/4, which is x to the 1/8. And then this is 1 over x to the 1/3. And if I just wrote it as a single exponent, x to the negative 1/3 power. So either of these here. All right, so that's it for the notes for the day. If we have time, we'll go to the Desmos and you can practice some on your own, and we'll look at some of them together. If not, then you're going to have to practice on your own.